We're going to go over your Chapter 8 review on polynomials. So number 1, a polynomial with two terms is called a binomial. Remember that prefix bi means two, like if I think of a bicycle has two wheels. So two terms means binomial. A monomial, which is one term, or the sum of two or more monomials. So think either I have one monomial or I have a bunch of monomials added together, a bunch of terms added together. So this is called a polynomial. And the way we remember that is the prefix poly means many, so many monomials. A polynomial with highest degree of 2 is called a quadratic. Number 4, put in standard form and then name. Remember, standard form is from highest exponent to smallest. They keep the same coefficients and signs. So this 3x cubed is going to stay positive. Then I have a negative 9x and a negative 5. So that is in standard form because it goes from an exponent of 3 to 1 to 0. And then I name this exponent by saying it is a cubic because its highest exponent is a 3, trinomial because it has 3 terms. Number 5 in standard form, that would be 3x squared plus 12x minus 4. Remember, all the signs need to stay the same. The squared term is positive, so it's going to stay positive. The x term is positive, it's going to stay positive, and the number is a negative 4, so it's going to stay negative 4. The highest exponent here is a 2, so this is a quadratic trinomial. Once again, trinomial because it has 3 terms. Think of the prefix tri means 3, like a tricycle has 3 wheels. Number 6, this is in standard form already, and this is a constant because its highest exponent is 0, and it's a constant monomial because it has 1 term. Think constant because if I look at that monomial of 5, there's no way that it can change. It's just always going to be 5. It's going to stay 5 and stay constant. Number 7 in standard form is negative x plus 2. This is a linear binomial. It's linear because its highest exponent is a 1. If I would graph that function, it would create a line on a graph. And it's a binomial because it has 2 terms. Simplifying expressions in polynomials. These are combining like terms. Since there's just a positive sign here, that's not going to change anything by distributing a positive 1. So I can go right into combining my like terms. Some like terms I see are this 2v cubed and negative v cubed. And then I also have some like terms of negative v and positive v. So when I combine my 2v cubed and negative v cubed, remember that's like a negative 1v cubed. So 2v cubed plus negative 1v cubed is now 1v cubed, or just v cubed. And then negative v plus v cancels each other out. So my final answer is just v cubed. On b, though, I have to distribute this negative. So this is going to change this expression to say 8z cubed minus 3z squared minus z cubed. And then I have minus a negative. So that's going to turn positive z squared. Then combining these like terms, I see a cubed z here and here. So those are like terms. And then I see a squared z termed here and here. Remember, the coefficients and the signs in front of the variables go with them. So 8z cubed minus z cubed is 7z cubed, and negative 3z squared plus z squared is negative 2z squared. Simplifying expressions. In numbers 9 and 10, we're going to do the distributive property, or rainbow rule, and you have to remember those exponent rules. So my first rainbow is 5 times k times 3, which would be a 15k. And then 5 times k times negative 4 times k. So 5 times negative 4 is a negative 20. And k times k would be k squared. In number 10, same thing. We're going to do the distributive property rainbow rule here. Negative 2 times x squared times 4 times x cubed. So negative 2 times 4 is negative 8. X squared times x cubed. Remember, that's like saying I have 2 x's and then 3 x's. So I now have x to the 5th. My second rainbow, negative 2 times negative 5 is a positive 10. X squared times x would be x cubed. And the last rainbow, negative 2x squared times a positive 2 is negative 4x squared. On numbers 11 and 12, you're either using FOIL or the box method. So my first terms, I have x times x, which is x squared. Then I have my outside terms, which is x times positive 12, which is a positive 12x. My inside terms is a 1 times an x, so that's a positive 1x. And my last terms is a 1 times a 12, which is a positive 12. These are like terms here in the middle, so I can combine them. So my final answer is x squared plus 13x plus 12. If you're choosing to use the box method, your setup would look something similar to this. Remember, it doesn't matter if my 4x goes on the top or along the side, as long as 4x and -5 are along the same side. And then 2x and -2 are along the same side. So when I find the area of this top left box, 2x times 4x is 8x squared. The area of my top right box, 2x times -5 is a -10x. The bottom left box, -2 times 4x is -8x. And the bottom right box, -2 times -5 is a +10. Same thing here. These two boxes are like terms, so I can combine them when I write my final answer of 8x squared minus 18x plus 10. On 13 and 14, when I square something, that means I take it times itself. So this means that I need to take 2x plus 4 times 2x plus 4 because all of that is being squared. Same thing here. If you use box or FOIL, either way, your first terms, 2x times 2x is 4x squared. Your outside terms is a +8x. Your inside terms is a +8x. And your last terms is a +16. I can combine those like terms in the middle to get a final answer of 4x squared plus 16x plus 16. Remember, you can also use the shortcut on problems like numbers 13 and 14 of squaring the first term. So 9x, all of that squared, 9x times 9x is 81x squared. Double the product of the two terms in the inside. So the product of the two terms in the inside is -2 times 9x, which is -18x. And doubling that is -36x. So I squared, doubled the product, and now I have to square the last term as well. So -2 times -2 is a +4. If you didn't realize that shortcut, you could also do 9x minus 2 times 9x minus 2, and that will give you the same answer. Number 15, a rectangle has dimensions of 3x plus 5 and x plus 7. Write an expression for the area of the rectangle as a product as a polynomial in standard form. Remember, this is not a polynomial. What I have written right now is a binomial times a binomial. It is not a polynomial. So in order to find the polynomial, I need to FOIL or box that and expand it. So after expanding that, I would have 3x squared as my first terms. My outside terms would give me plus 21x. My inside terms would give me plus 5x. And my last terms would give me a plus 35. And then it's asking me to put it in standard form and combine my like terms. So I'd have 3x squared plus 26x plus 35. That is the area of that rectangle as a polynomial. This is a polynomial, because remember, a polynomial is a monomial or a sum of many monomials. Factoring. Whenever you're asked to factor something, you always check for a greatest common factor first. Check to see if there's a GCF, which in number 16, there is. The GCF for number 16 is 4, and they also all share a p, and the smallest of those exponents is just a p. So I'm going to take out a 4p. Now going from 4p to 12p to the 4th power, I need to multiply by a 3, and I need 3 more p's, so 3p cubed. To go to that second term, I need to multiply by a +4, and I need 2 more p's. And then to go to the last term, I only need to multiply by a +2 because I do not need any more p's. That is as far as you can factor that form. On number 17, I'm going to look for factors of 14 that subtract to be 5. Factors of 14 that subtract to be 5. So my factors here are 7 and 2. I can go right into my binomial times my binomial because I have no coefficient attached to my x squared term. Then I need to create a -5. In order to create a -5, I do -7 plus 2. So that is my factored form of that trinomial. And number 18. Remember when I look for product of factors, I have to do this product here since there's a coefficient. So I'm looking for factors of 2 times 2 that subtract to be 3. So 2 times 2 is 4, and factors of 4 that subtract to be 3 are 4 and 1. These ones involve an extra step in them. So on these problems, I need to first bring down the first term, which is 2n squared. Then I need to create a +3n. In order to do that, I have 4n minus 1n minus 2. Then I split this in half and take the GCF out of both. The GCF out of my first half is 2n. Then what's left over is n plus 2. The GCF of my second half is a -1. Then what's left over is an n plus 2. Then remember, we take the outside terms to create one binomial. So you have 2n minus 1, and then you take only one of the binomials that are matching up, n plus 2. So this is your factored form of that trinomial. On number 19, we are looking for factors of 40 that subtract to be 6. Factors of 40 that subtract to be 6. Those would be 4 and 10. Remember, I can go right into my binomials because there's no coefficient attached to the squared term. So I have an x and a 4, and I have an x and a 10. I need to create a positive 6. The only way to do that is a positive 10 minus 4. Number 20 is two terms, and it is a difference of two perfect squares. So to factor a difference of two perfect squares, I take the square root of this first term. The square root of that is x, plus the square root of this term, which is 7. And then I do the same thing, but then I have a minus. So I have square root plus square root times square root minus square root. On number 21, I'm doing factors of 100 that add up to 20. Factors of 100 that add up to 20. My factors of 100 that would add up to 20 are 10 and 10. So I have x and a 10, x and a 10. I need to create a -20. The only way to do that is -10 minus 10. 22 is a difference of two perfect squares, just very similar to 20. So the square root of this first term is 5x, plus the square root of the second term is 9y. And then I have square root minus square root. On 23, we're going to factor this as 4 terms, so I factor it by grouping, splitting it in half, taking the GCF out of both. The greatest common factor of the first half is 3. They all share a y, and the smallest exponent is a squared. To go from 3y squared to 6y cubed, I need to multiply by 2, and I need one more y. To go from 3y squared to -3y squared, I need to multiply by a -1. The GCF of my second half is just a positive 1. Then I need to multiply by 2y minus 1 to get to that second half. Then I take what's on the outside, which is 3y squared plus 1, and the one binomial that is matching up, 2y minus 1. 24 is going into some review with some exponent properties. If I have power to a power, I need to distribute that power to everything. So I have 5 cubed, and then I have x squared cubed. So 5 cubed is 125, and then x squared cubed. That means I have 3 groups of x squared, so that would be x to the 6th. On B, I need to look at simplifying this fraction first, 9 over 12. So I can see that I can take a 3 out of both, so that would simplify down to 3 over 4. Then I have this negative exponent on my y, so I'm going to bring him to the bottom and change him to y to the 4th. So then I have y to the 5th times y to the 4th. So I have 5 y's, then 4 y's. So that's now 9 y's, and they're going to stay on the bottom. So my final answer would be 3 over 4 y to the 9th.